Imagine you're standing in front of this massive, heavy steel bank vault.
Okay.
You spin the dial, you hear that heavy mechanical click, right? And you pull on the handle just to verify the door's locked tight.
Right, doing the whole double check.
Exactly. And you walk away feeling totally secure. But, like 30 minutes later, you're sitting in your office, and this thought pops into your head.
Oh no, did I actually lock it?
Yes. Is the vault actually locked? I mean, you checked it. But the only proof you have right in that moment is, well, your own memory of the event.
Which is, I mean, human memory is notoriously unreliable, right?
Completely. And in our daily lives, relying on memory for things like that is, pretty standard. But when you apply that exact same logic to complex systems or like software architecture.
Yeah, that's a dangerous game.
Yep.
Relying on a memory of a check is just, it's asking for trouble.
It really is. Welcome to today's deep dive, by the way.
Hi, everyone.
Our mission today is to unpack this highly specific, but honestly fascinating programming philosophy. It's known as Parse, don't validate.
Yeah, it's a profound shift in thinking.
Right. And we are getting our hands dirty today with some real-world source material straight from the trenches of software development.
Real code in the wild.
Exactly. We've got a journal entry from a developer named Ang. Specifically, we're looking at part 195 of their ongoing series. It's called Notes-on-Haskell-Programming, published July 24th, 2026.
And what Ang is doing here is chronicling this incredibly meticulous process of refactoring a command line application.
Right.
And while context is super technical, the underlying logic Ang is wrestling with, well, it offers a really compelling way to rethink how we handle information in, like, any structured environment.
So even if you have literally never written a line of code in your life, this concept is going to challenge how you organize your own workflows.
Absolutely.
We're talking about transforming how we trust incoming data, demanding structural, undeniable proof rather than just, double-checking things and crossing our fingers.
Yeah, hoping for the best is not a strategy.
No, it's not. But to really appreciate the brilliance of the solution Ang landed on, we first have to kind of look at the mess they were trying to escape.
The before state.
Yes, the before state of this code base. So in the original code, Ang had this function, and it was called validate_args.
Right, and taking in arguments and validating them, I mean, that's a standard, almost reflexive pattern in programming. You know? The user types something in, and the system runs a quick check.
And in this case, the function took in something called an args record, which, for those of us looking from the outside, what exactly is sitting inside that record?
Yeah, so think of the args record as like a simple intake form.
Okay.
It holds the raw, totally unverified inputs that a user just typed into the command line. It's got fields like input path, which is, wherever the user claims their file lives.
Claims being the operative word there.
Exactly. Maybe there's an output format field and like a little toggle flag called tidy, but it's really just a container for user requests.
So the user hands over this intake form, and validate_args goes to work. What is that function actually looking for when it processes the record?
It's basically looking for baseline sanity and security.
Right.
It asks the operating system, like, hey, does this file path actually point to a real file? And if it does, is it a text file? If we open it up, is the content valid UTF-8 text? Or is it just, a jumbled mess of binary data?
So these are critical questions before the app tries to do any heavy lifting.
Right. You have to know what you're dealing with.
But here is where the source material highlights this massive structural flaw.
Yeah, the fatal flaw.
Before Ang made this big refactor, that args record, that basic intake form, it was being passed around the entire code base regardless of whether those sanity checks had actually been completed.
Which is terrifying, structurally speaking.
Right.
You have this package of data moving through the system, and merely by looking at the data itself, a developer has absolutely zero idea if it's safe to use.
It could be completely raw.
Exactly. It could be potentially application crashing data.
Let me offer an analogy here, because when I read this part of Ang's notes, it clicked perfectly for me.
Oh, let's hear it.
Think of that old validate_args method like a bouncer at a very exclusive club.
Okay.
You walk up to the door, the bouncer checks your ID, checks the VIP list, nods, and lets you inside.
Standard club stuff.
Right, but they don't give you a wristband, they just open the door. So now you're inside the club, walking around.
Then you go to the bar.
Exactly. You go up to the bartender to order a drink, but the bartender looks at you and has absolutely no idea if you were actually checked at the door.
Or if you just, snuck in through the kitchen.
Exactly. The ARBS record is you walking around the club with zero proof that you were vetted.
And the bartender is left entirely in the dark. That missing wristband, that's what developers call structural ambiguity.
Structural ambiguity. I love that term.
And, well, the situation gets even more complicated when we look at how the validate args function handed the data back, even when the checks were successful.
Right. The notes mention it returned this primitive untyped tuple.
Yeah.
It looked like this in the code, like literally a parenthesis, the word args, a comma, the word byte string, and a close parenthesis.
Right. And a tuple is essentially, it's the most generic container you can use in programming.
Just a basic box.
Yeah, it just groups items together by position, item 1, item 2. There's no label, no context, no inherent meaning attached to that pairing at all.
Ang also specifically notes that the second item in that tuple was a lazy byte string, which was written as bl.bytestring.
Yeah.
What does lazy mean in this context, and why does it make the lack of a wristband even more dangerous?
So in programming, laziness means deferring work until the last possible second.
Procrastinating for computers.
Basically.
Mm-hmm.
A lazy byte string doesn't load the entire file into the computer's memory all at once. It reads it in chunks, only when the program explicitly asks for the next piece.
Which sounds good, right?
It's fantastic for performance, yeah, especially if you're processing a massive file. But if you haven't rigorously validated that file up front, laziness becomes a trap.
Oh, because it hasn't actually checked the whole file yet.
Exactly. You might be 10 minutes into a complex operation before the program finally tries to read a corrupted chunk of the file.
And then what happens?
At which point the entire application crashes in the middle of a process.
Wow. Okay, so the full function signature for this operation was IO, open parentheses, iter apperer, then that tuple we talked about, args, comma, bl byte string.
Yes, quite a mouthful.
Let's demystify that for a second. What is that either command actually doing?
So the either type is a really fantastic tool for forcing a program into two distinct lanes.
Okay.
It tells the system, hey, this operation will result in either a failure, which we will route to the left lane, or a success, which we will route to the right lane.
Okay, so the left lane here is apperer, meaning something went wrong, like maybe the file didn't exist.
Right. And the right lane is the success state, which hands back that primitive tuple.
Right, so the function forces you to handle the error, which is good.
Yes.
But if you land in the success lane, you are still just holding that generic unlabeled tuple, just two items sitting next to each other in parentheses.
Exactly. There's nothing inherent to a tuple that says, hey, these items have been rigorously checked.
Right.
The system has to rely entirely on the programmer remembering that this specific tuple, coming out of this specific function, means the data is safe to process.
So we are right back to the bank vault problem.
They are.
Relying on human memory rather than a structural guarantee. I mean, if a new programmer joins the team or if Ang comes back to the code 6 months later, they might see that tuple, forget the context, and accidentally pass unvalidated data into a critical part of the application.
Yeah, and that is the day-to-day headache of working with untyped primitive data. It's really a ticking time bomb disguised as functional code.
Which brings us to the paradigm shift.
Yes.
Because relying on memory inevitably leads to a crash, Ang realizes the data needs a permanent wristband.
Exactly.
It needs to wear its proof of validation at all times. And this is the move from validating to parsing.
This is the real turning point in Part 195 of the journal. Parse, don't validate, goes from being just this catchy slogan to actual functional architecture.
So Ang goes in and introduces a brand new, strongly typed representation of the data. They create a record explicitly named ValidInput.
Right. Not args, not a random tuple.
ValidInput. And this new record contains exactly two fields. VI args, holding those original arguments, and VI content, holding that byte string.
It's a dedicated structure, clearly labeled with a very specific intent.
And to deploy this structure, the function is entirely rewritten and renamed. It goes from validate args to parse input.
A huge distinction.
And the new signature returns IO, open parenthesis, either apper or valid input.
Right.
The core philosophy Ang states here is that valid input now acts as indisputable proof. It is proof that the input file exists, that it's a text file, and that it's valid UTF-8.
Yeah. Ang writes, quote, any calling code that uses the valid input parameter is guaranteed to never run on unvalidated input.
The anxiety is just systematically removed from the codebase.
Now, I have to play devil's advocate here on behalf of the listener.
Go for it.
Because when I first read through this source material, I had a moment of, serious confusion.
Really? How so?
Well, isn't Eng just putting the exact same two items, the args and the byte string, into a new box with a fancy name?
Oh.
I mean, the checks are the same. The data is the same. Why does naming a box valid input magically make it proof? If I take a cardboard box full of junk and write treasures on the side of the Sharpie, it's still just a box of junk.
That is a great analogy. And that critique cuts right to the heart of why this concept is actually quite difficult to grasp at first glance.
Right.
To understand the mechanics of this shift, we have to look at the difference between an action and a state.
Okay, unpack that for us.
So validating is an action. You check the file, you nod your head, and you move on. The action is ephemeral.
It happens and is gone. It vanishes the moment it's completed. But parsing, at least in the context of this specific programming philosophy, means taking unknown, potentially dangerous data and actively translating it into a highly specific, restricted type.
Okay.
You were translating it from a state of unknown into a state of known.
Translating it into the valid input type.
Yes. And here is why it isn't just writing treasures on a cardboard box. We have to look at the role of static typing and the compiler in the Haskell programming language.
Oh, the compiler.
Yeah, a compiler is essentially the foundational program that translates human-readable code into the machine language a computer can actually execute. Think of the compiler as the most pedantic, unbending proofreader you have ever met.
It reviews the logic before the program is even allowed to run.
Precisely. And in a statically typed language like Haskell, you can set strict rules about how certain data types are created.
Okay.
So Eng structured the code so that the valid input record can only be generated from inside the parse input function.
Wait, really?
Yes. The compiler acts as an enforcer. If a developer tries to manually conjure a valid input record out of thin air to bypass the checks,
Yeah.
the compiler will literally refuse to build the program. It will throw an error and halt everything.
Wow. So the environment itself enforces the security?
Exactly. Because valid input can only exist if the checks inside parse input were completely successful, its mere existence is the mathematical proof.
That's incredible.
I never have to wonder if the checks were run, because if they hadn't been run, you physically wouldn't be holding a valid input object.
Right.
The compiler is enforcing the safety, not the programmer's memory. It's the difference between a bouncer checking your ID at the door versus a nightclub where the doors literally do not exist unless you are over 21.
The door just materializes out of thin air once the proof is established. I love that.
It's wild, right?
But what does this actually mean for the day-to-day life of a developer? Because Eng notes in the journal that pulling this off took quite some moons.
Yeah, that's a great phrase.
It wasn't just a quick 10-minute fix. It was a significant investment of time. What is the pragmatic payoff for going through all this trouble to appease the compiler?
Well, the payoff really comes down to anticipating the future, extensibility.
Okay.
Eng explicitly states that the main benefit of this approach is future extensibility during command line parsing.
So let's look at the alternative. In the old system, Eng was using that primitive tuple, the args and byte string.
Right.
Imagine Eng's project grows, and suddenly they realize they need to track a third piece of metadata. Like maybe they need to track the timestamp of when the file was last modified alongside the arguments and the content.
Right. Modifying a tuple to add a third element is an absolute nightmare in a large code base.
To visualize why, think of that primitive tuple as a rigid 2-slot briefcase.
Okay, I'm picturing it.
It's made of hard, molded plastic. It has exactly 2 slots cut out, one for the args, one for the byte string. If you suddenly need to carry a third item, you can't just force it in. There's no physical room. You have to throw away the entire briefcase, buy a brand new 3-slot briefcase, and then completely reorganize your entire filing system to accommodate the new shape.
And in a software environment, changing a 2-item tuple to a 3-item tuple creates massive, cascading, breaking changes.
Everything just shatters.
It does. Every single function in the entire application that was expecting to receive a 2-item tuple now throws a fatal error because it is suddenly being handed a 3-item tuple.
Wow.
The pipeline shatters. You have to hunt down every single instance where that data is touched and rewrite the logic.
But with the new valid input record, it's a completely different story. It is not a rigid briefcase.
What is it then?
It's more like a modular backpack. You have your main compartments, but if you suddenly need to carry a water bottle, you just zip on a new side pocket.
Oh, that's perfect.
Ang just adds a new field to the valid input type definition. They add a VI timestamp field, and the rest of the backpack functions exactly the same.
Yes, and the existing code that reaches into the bag to pull out the VI args, it doesn't violently break just because a new pocket exists on the side of the bag.
Right.
Because the data structure has named fields, functions only interact with the specific pieces of data they care about. The rest of the structure can evolve independently.
It builds a foundation that actually embraces change rather than fighting it.
Which is what good engineering is all about, right?
Totally.
Whether it's in software architecture, civil engineering, or organizational management, it isn't just about making the system work today. It's about acknowledging that requirements will inevitably change tomorrow.
And Ang was planning for tomorrow.
By shifting from a fragile tuple to a robust typed record, Ang's refactor protects the future of the code base from the inevitable evolution of the project. You pay a tax up front, those moons of refactoring time, to buy yourself freedom and safety for years to come.
To quickly recap Ang's journey here in Part 195, the codebase started with a system that was deeply ambiguous. It relied on an unchecked args record moving freely through the system and a fragile primitive tuple that required the developer to simply, remember that validation had happened.
It was the bouncer letting you in without a wristband.
Exactly. And over the course of quite some moons, Ang upgraded this architecture to a bulletproof, strongly typed valid input record.
Yeah.
By shifting the philosophy from validate args to parse input, they created a compiler-enforced proof of validity that entirely removes human memory from the equation.
While simultaneously preventing future breaking changes, it really is a masterclass in defensive design.
It is.
You make the right way to do things the easiest way, and you make the wrong way to do things completely impossible.
That brings us to a broader concept to mull over. As we said at the start, you don't need to be a Haskell programmer to apply the brilliance of this philosophy.
Not at all.
Consider the systems you interact with every day. Think about how you organize your digital files, or how you hand off projects to a team at work, or even how you set up your own personal daily workflows.
You should audit those processes for hidden dependencies on human memory.
Yes. How often are you relying on your own memory or a colleague's memory to know if a critical step has been completed?
Are you passing around a metaphorical args record, just hoping someone else verified the contents?
Exactly. What would it look like to redesign your systems so that a task literally cannot move forward to the next stage unless the structure itself proves it was done right? What does your version of valid input look like?
If you design systems where the output inherently proves the validity of the process, you remove immense amounts of daily friction and anxiety. You stop validating and you start parsing.
It is all about moving from hoping things are right to mathematically knowing they are.
Beautifully said.
So, the next time you find yourself double-checking a metaphorical ID at the door, ask yourself, are you just nodding them through or are you handing out wristbands? Thank you for joining us for this deep dive into Ang's refactoring journal. Until next time, keep questioning the systems you trust.